Okay, good morning, everyone, and welcome to SpaceGeekSpeak. And as you know, SpaceGeekSpeak is our weekly Saturday morning get together, networking, and with the invited speakers event sponsored by AAA Houston section. Today, we have a pleasure of welcoming Captain Erin Edwards from the Royal Canadian Air Force and NASA Johnson Space Center. At the moment, Erin's career has been anything but conventional. She began in geological exploration, managing projects in some of the most remote regions of northern Canada and Alaska, before pursuing military aviation career with Royal Canadian Air Force. As a Griffon helicopter pilot with 427 Special Operations Aviation Squadron, she served as both an operational pilot and flight safety officer, deploying twice to Iraq and accumulating more than 300 combat flight hours. Her passion for space eventually brought her to NASA. In 2023, she became the first Canadian astronaut coordination officer, representing the Canadian Space Agency at Johnson Space Center. After completing NASA's Spaceflight Controller Academy, she made history again by becoming the first non-astronaut to serve as NASA's Deputy Branch Chief for Crew Operations. She is also qualified as an International Space Station CAPCOM, serving as critical voice between astronauts aboard ISS and mission control. Most recently, Erin has been helping shape the future of human exploration by leading the integration of helicopters into NASA's flight training for Artemis, work that earned her NASA's Stephen Thorne Top Fox Award for creating a helicopter training program that supports lunar analog operations and helps reduce risk for future moon missions. And what makes Erin's story especially compelling, it's just not the list of accomplishments. It is the breadth of experience that connects military aviation, human spaceflight exploration, astronaut support, international collaboration, and the practical realities of preparing people to explore beyond Earth. Today, we'll hear about her personal journey, gain behind the scene, potentially, insights into ISS operations and CAPCOM, and discuss how NASA, Canadian Space Agency, and Royal Canadian Air Force work together to enable human exploration and learn what it takes to prepare astronauts for the next era of lunar missions. Please join me in welcoming Erin Edwards. Erin, thank you very much for being with us today. We're delighted to have you on Space Geek Speak.
Oh, well, thank you so much. And thanks for finding me on on NASA Teams there. I appreciate the invite, Svetlana. You guys are all probably super accomplished as well. I looked at your resume, Dr. Hansen. So I feel definitely humbled to be here today, but always happy to talk about space.
Okay, well, it's our meeting today will be structured more of the question answer, and
Yeah.
so if we can go. I shared the list of questions with you that I thought that would be interesting.
Mhm.
So we can go over that list, or if you want, you can just start with a little bit about yourself. I think I captured a lot, but I'm sure there's a lot to
Well,
left.
yeah, I think you captured most of it, but you're right in that I've had a really interesting career. I wasn't in the Air Force first. I was actually in the Navy as a warfare officer and a diver because I didn't get into the Air Force first. So I actually had another career after geology before I even made it to pilot. But I think all of that experience has been represented here at NASA. It's all been leveraged, which is pretty cool. But hit me with your questions. I think they were pretty good.
Okay, well, you started in before NASA in the Royal Canadian Air Force and ended up supporting, not ending your career yet, but right now, supporting NASA human spaceflight. What moments or decisions shaped that journey the most?
Yeah, I think that's a good question. And I think for me, I think, like I mentioned before, I didn't get into the Air Force first. I ended up in the Navy. In Canada, the only people that fly aircraft are Air Force officers, and we'll loan them out to different communities. Your services down here in the States, everyone has aircraft to fly. So I was definitely disappointed that first time. So I think the thing that impacted my journey the most has probably been failures along the way, because I was really trying to do something and it wasn't always turning out. So I think the decision to sit down with failures along the way, whether it was a flight or I didn't get into flight training or whatever else, took me 3 tries just to get into the Air Force. I think those decisions over time kind of helped me realize that failure is actually a bit of a guide. It probably means that I'm trying really hard at something and I should just stick with it, because I'm probably also quite stubborn. But I think that was probably the biggest thing that impacted my journey after I decided that I wanted to somehow, as a Canadian, get to NASA. Not the easiest route, but that decision was made quite young. Like I was 9 years old, listening to Dr. Robert Thirsk, a Canadian astronaut from a million years ago, talk about space. And then from there, it's just like, I want to do this thing. I don't know how. I know it's going to be hard, and just sticking with it. So that decision to keep going, I think, is probably the most decisive thing I've ever done.
So if you could go back and give your younger self one piece of career advice before entering aerospace, what would that be?
Yeah, I think it would be to keep going. I wish someone had told me that this was going to be really hard, right? You kind of look around at other people in aerospace, especially pilots sometimes, and some of them make it look really easy. When in actual fact, I think a lot of us are probably back in our rooms in the barracks studying really hard, but a lot of people seem to make it look like it was naturally easy. And I didn't understand why it was so hard for me. It turns out it's hard for a lot of people. I just wish I'd known that when I was younger, that there are going to be bumps along this road because you've chosen to do something difficult in aerospace. And that could be research, it could be any of the jobs that people have in aerospace and space. But I think the understanding that you can just stick with it and ride through some of the most difficult parts, and maybe find a mentor to remind you of that every so often. I kind of wish I'd known that when I was a little younger. I think I would have stressed myself out a little bit less if I knew other people were also having a bit of a hard time.
It's a struggle, but
Yeah.
determinism definitely pays, right?
Yeah.
So looking back over the past 3 years at NASA, what experience exceeded your expectations the
Yeah.
most?
I think that's a tough one, because having been integrated into so many different parts of the human spaceflight mission at Houston has exceeded my expectations as like a Canadian helicopter pilot. But I think the thing that has struck me the most or exceeded my expectations is I knew I was going to be part of a team, but I didn't know I was going to be part of so many nested teams at NASA. It's a massive, as you guys know, it's a massive integrated team. And my experience is in human spaceflight, but there's a localized team every time with different people in the flight control room when you show up, because I go there, every couple times a month. And then there's a team in the astronaut office. There's teams that train the astronauts. There's teams at Johnson. There's teams that reach back to Canada, Japan, Munich, Russia, like all these different places. So I think what exceeded my expectations was how much of an integrated team you get to be a part of at NASA.
Fair. Most people know that astronauts, but far few understand that people supporting them from the ground. Um, what does a typical Capcom day actually look like?
Yeah, that's a good question. In fact, I'm on call tomorrow, so it's probably a good time to chat about that. There's a huge amount that happens in the flight control room. The Capcom console is the least technical of the consoles. Our system is to support the astronauts and communicate the intent of the flight director and the other flight controllers, often digesting and contextualizing what all the super smart engineers are saying into astronaut speak. The astronauts know a lot about station, but they're operators. They're not the subject matter experts. So sometimes it's very challenging to kind of, you're talking to all the different flight controllers that are super smart in their system, but you help them kind of bake down the message to the context that the astronauts need. So in order to do that, it is nice to get ahead of the game a little bit. So you check the schedule before you go. And the schedule for astronauts is measured down to the 5-minute increments. So each astronaut has all their activities laid out for the day. And what I do is I like to make sure that the astronauts I'm responsible for, which is usually the US or the international partner astronauts, I'll look at the Russian schedule, but usually they're a little bit self-contained. Just want to make sure there's no spatial constraints, that if we're doing a lot of payload activities, that we have the right frequencies assigned for everyone and there's no overlap. Make sure that I understand the procedures that I'm going to be interacting with and go through all of that. So I tend to pick up a lot of shifts for people because I don't mind working overnight. So a typical day for an orbit 1, which is 12:30 in the morning till about 8:30 Houston time, and that matches the beginning of the astronaut day. They're on Greenwich Mean Time, so we kind of match our day to them. And so I'll get there about an hour and a half before the astronauts wake up, make sure that I'm happy with my console and my system. I've done all my prep work. I'll talk to the flight director who gets there a little bit earlier, make sure there's nothing that they're tracking. And then I'll actually check in with the other communicators. So not everyone knows that it's not just CAPCOMs, but each of the international partners, so Munich, Scuba Japan, and Moscow, each have a communicator, as well as Huntsville. Huntsville manages all the payloads. So I'll check in with them to make sure that they're happy and I'm not expecting anything unusual. And we'll sometimes deconflict the frequencies we're each going to work on, because sometimes the different communicators will work with an individual astronaut for a specific experiment or maintenance action. And I kind of have to oversee everything as the NASA CAPCOM. So then your day starts and the crew wakes up. We start with a planning conference, go over anything that may have changed overnight when we sent them their schedule. They look at that before we all have a call down. And that's everybody. So the Russian crew and the American and international partner crew, we all get together and have a daily planning conference. And like I said, go throughout the day, make sure we're all happy, let them know if there's any changes or anything to expect. And then we hand it over to each of those international control centers. They'll do, if they have any points, they'll pass them along. And then the Moscow folks will update the Russian crew on what they're doing for the day. And then we just kind of carry on. And the astronauts will call down if they have to in the procedure or if they have a question. And you just kind of manage the day as it goes along. And then for orbit 1, we hand over to another CAPCOM that's around the astronaut lunchtime. And then obviously, if you've been working overnight, I go home and I get a nap. And then I usually go back to work. And it's kind of the same thing if you're the orbit 2 CAPCOM, you're 8:30 until about 4:30 in the afternoon Houston time. And that's midday meal to the end of the astronaut day. And that CAPCOM will do an evening planning conference to let them know what's happening the next day, kind of go over what we did. And then we sign off and let the astronauts have a bit of personal time before they go to bed. So some days are super boring, not boring. No time in mission control is boring. Some days are quiet, which is fantastic. And then other days, something breaks or an experiment isn't working, or it's just super busy. There's public affairs activities happening, and it can be extraordinarily busy. Some of the experiments and the maintenance actions are very complex. And when you look at those days, sometimes it's just a lot. But when we have dynamic events like the Northrop Grumman crew resupply vehicle that I was a lead CAPCOM for, that is a very specialized shift. We have a specialized flight control team that trains together. And on days like that, you are on the edge of your seat for about 11 hours, especially when things are flying in formation at 17,000 miles per hour. Similarly, we might have 2 CAPCOMs on console for extravehicular activities. One CAPCOM will take care of internal communications, and one specialized CAPCOM will take care of the EVA as it's happening outside station. So we all specialize in something. I specialized in robotics, maybe because I'm Canadian and a big fan of robotics. So as a CAPCOM, we worked pretty closely with the robotics officer to make sure we understood their procedures, and I knew what to expect when the astronauts were capturing a vehicle with the arm, and I did that same class as the astronauts. So it's been pretty cool. CAPCOMs, we do a lot of the same classes as the astronauts, so we know what they are doing on station and what to expect. So if there's a problem with, I don't know, the seal on the hatch when they're doing maintenance, I've done that same class. I know what to expect. So if I'm interacting with other flight controllers, I know a little bit of what I'm talking about. But the breadth of knowledge required for CAPCOM is pretty vast. You have to know a little bit about a lot of different things. And the other flight controllers, they deep dive into their own system. So it's a really interesting team. It's a really long answer to your question, but that is a typical day for a CAPCOM.
Is there any specific preparation that goes for that may that you need to do for conversation that may only last a few minutes with the crew on orbit?
Good question. I think that preparation is probably our training, which takes about a year. And we do a lot of simulations where we have essentially an entire flight control team. We have data, we have a surrogate crew, and we'll all kind of get into this sim and have a really bad day. The whole point from the training team is to try and break everything. And you have to work with the flight control team and the flight director who owns all the decisions and the risk. And it's our job to learn how to break down what's going on and give that context, the intent and the actions to the astronauts in a relatively short amount of time. So I think we learn it by practicing things in the sim. But otherwise, we're encouraged to kind of be ourselves as Capcoms. We're like the only two people that they're speaking to generally, other than maybe some other payload Capcoms or payload communicators. So yeah, you learn how to kind of transmit your message as succinctly as possible. I'm not doing a great job of it right now in this conversation, but I think that's primarily our training is in our emergency sims, because sometimes we only have a few seconds to get a message out. So we will practice that kind of thing repeatedly for a year in varying levels and increasing difficulty simulations with the entire flight control team.
So basically, lots of practice
Yeah.
in during training, right?
See, I think you could be a Capcom. That's exactly what I was trying to say.
Great. Was there anything that surprised you when you first became involved in ISS crew operations?
Yeah, again, I think it was the size of the team that supports the astronauts, not just during launch, but when they're in orbit. We've been doing this for 25 plus years. And the fact that these teams are international. We have different modules on ISS that are built by different countries, and each one of those countries has input. We have commercial partners that build these amazing resupply vehicles or crew vehicles, and we're involved with them as well. So I think that is what was probably most surprising, is just how intensely large some of these teams are, but they're all driving to one thing, and that's crew safety. That's like the overarching thing. And I think that's kind of cool as I think about it, if that answers your question.
It did. It did. Thank you. Without sharing anything sensitive, can you tell us about memorable moment where teamwork on the ground made a real difference in space?
Yeah, I mean, there's been so many, right? I wasn't involved in Crew 11, but I'm sure you heard about that, where there was a medical urgency to return the crew a little early. I was not involved in that as a flight controller, but what it was important to me to see, and I think it was interesting, and I wish the stuff was more widely available, but the whole team here at Johnson Space Center kind of pulled together to figure out the best way to get that crew back while also assessing potential impacts to the folks that were going to be left on station. And it was just how methodical that whole situation was to protect the crew in all phases of that plan to return Crew 11 early. And I think it was really neat to see, because these, like I said, I keep saying these teams are huge. They are massive, and integrating that amount of data quickly to make the right decision is challenging. And so kind of watching it happen in the background, I was really impressed. But I'd say almost every day we're doing something that impacts crew to make sure that they're safe. And a lot of those decisions, you can actually see it in real time in the flight control room as the flight controllers and the flight director are having this discussion. And it's really neat to see. I just get to tell them, tell the astronaut what's going on, but watching everyone else make these really important and timely risk mitigated decisions is really neat to see. So I'd say that's probably the most recent one that I can think of, where the team did such an excellent job of coming together, quickly assessing that risk and making a challenging decision, right? The decision to return a crew is very challenging, right? There are residual potential risks to the crew that's left on orbit, but they did an amazing job and assessed everything. And I mean, the crew was also involved in that decision too. So it was really neat to see.
Since you mentioned that particular mission, I think that there's even more involving parts again because all the logistics have to be both assessed, changed, the schedule has to be reassessed again because they impact the snowball effect on everything, all the ground operations that happen pre and post the flight, and the impact to not just even to ISS, but other launch facilities and on and on and on. So there's way more with that particular case.
Yeah, it's
Was
a huge, yeah.
Yeah, I can only imagine. Yes.
It was pretty impressive though, and I'm proud of the teams because they did such an amazing job of integrating all of that, and like we've carried on right post Crew 11, we're launching Crew 13 in September, and there was impact to the schedule on orbit, but I mean everyone just kind of flexed and readjusted, and so it's really interesting to see how flexible such large teams can be, and I think that happens because everyone understands the intent, and the overarching intent for everyone who works in human spaceflight is crew safety. So we're making all decisions based on that, right?
Yeah, cool. Communication in space has to be concise and unambiguous. Have those communication habits influenced how you approach everyday leadership?
I was told before that I can be a little bit direct sometimes, so I wonder if it's the other way. When I need to be very concise and direct, I can be. When there's time for me to offer context, I will. But again, I think, like I was just mentioning before, I'm going to keep harping on this because I think it's really important. What's probably changed or influenced my leadership, maybe I was recently promoted to major. It took a long time because I wanted to keep flying. Thank you very much. But I think what I'll take from here is that NASA does a good job of trying to provide as much context as possible. And it is so much easier to be a leader when you can tell the people that you're working with why it is they're doing something. And then you can kind of go hands off. So I found that as a Capcom, the flight director, we sit right next to each other. So I'm kind of middle back in flight control, and the flight director is kind of in the center on my left. And half the time we're talking about very complex engineering stuff. And I'm like, flight, what's the context here? And they'll help me break that down into context. And then I know what to say. So I feel like it's the same thing in other areas, whether you're working in a team or in leadership, that if you understand the intent or the why of the thing that you're doing, it makes it so much easier for the team. So just to make sure, if I find myself in more leadership positions, that I'll try my best to ensure that I'm passing that context down to the team.
Thank you, Erin. So moving a little bit into a training area.
Yeah.
How many people were surprised to learn that helicopters play an important role in Artemis training? Could you explain why that capability is so valuable?
I'd say that everybody was surprised. It's been interesting. I think once you sit down and think about it, it makes sense. So for a few years now, Anne McLean and Jasmine Mogbelli, call sign Jaws, they're helicopter pilots by trade and training in their military services. Them and Douglas Wheelock, one of our senior astronauts, were kind of looking at some of the Apollo data and thinking like, hey, every time one of these landers tried to land, it was moving around a little bit, trying to find the right spot. There's boulders, there's dust, there's all this stuff happening. And that process of like assessing your landing zone, potentially having to move things around, working in a vertical domain, and then kicking up a bunch of dust, but still being able to see and do what you need to do in the vehicle is very, very similar to helicopters. So they did a bunch of analyses and figured out that actually helicopters provide a pretty decent analog, not in terms of control. No one's going to have a 3-axis control, rocket landing on the moon, but all of those really difficult to train things. So you take a bunch of jet test pilots that are really used to going Mach whatever, and then put them in a vertical domain, it's a very different type of flying. So it's a little bit less about the hand control, and it's more about shifting your thinking into being in the vertical domain and then dealing with the dust that you're kicking up, because it does become a crew resource management problem. So when I've been flying in a helicopter in really challenging environments overseas, oftentimes it takes the entire crew. Even the people in the back of the helicopter, our flight engineer or door gunners, they're providing us information that I'm integrating, because I can only look at, say, a small rock in front of me to land this helicopter, especially the ones that I fly that don't have any fancy autopilots. So we're integrating a whole bunch of information to make a safe landing. And so we found through various types of analyses at all kinds of different levels for astronaut training that incorporating helicopters early for that crew resource management, learning how to work as a team, they know how to work as teams, learning how to work as a member of a bigger team while incorporating some of this feedback from people, while also working in a vertical domain and dealing with these degraded visual environments, was actually super cool and relevant analog training. So it took a little bit of convincing, but we're there. Yesterday, actually, we did our last ground maintenance run. So we're ready to fly the helicopters next week. Fingers crossed, if we don't find anything else when we put all the cowlings back on. But that's essentially the reason why. So we're going to plug that into primary space flight readiness training. So it's going to be about 40 hours. And we've already established this program with the Army National Guard in Colorado with Anne McLean and Jasmine Mogbelli. And that's a mountain flying course where they actually go practice these types of landings in the mountains where the aircraft isn't responding quite like you want it to. You're a little bit power limited and you really have to work as a member of a crew. And you're also under a bit of physiological stress because where we do that training, you're above 10,000 feet. So you're not necessarily hypoxic, but you have to keep constantly assessing how you're feeling and make sure that you put your oxygen on if you need to. So that's kind of like the graduate version of the helicopter course. And that's been in progress for quite some time. But to fill that gap where, that's very challenging, and the astronauts have been doing a very short introduction to helicopter flying. It's about 2 weeks with the Army. We found it wasn't quite enough. They did a great job, but we want them to have more skill in the helicopter before they go do this challenging mountain course. And that's what they left with me. They said, "You're a helicopter pilot. Can you just make us a program?" Sure, I'll do that for you. So that's why we've incorporated helicopters. There's a lot of different things that went into those training needs analyses and all kinds of tasks and duties that we can also train in helicopters. But the important thing to understand is that it's part of a spectrum of tools. So we're still going to use the jets because we know those are great training analogs for other things, being under, G loading and all that kind of stuff, going fast, doing really fast mental math. It is a challenging environment in itself, but also adding the helicopters for some of these other things that are very specific to lunar landing and larger crews working together. So it's a long explanation. There's a bunch of other stuff that goes into it, but I think a lot of people have been surprised. But if we think about how the mission is shifting from ISS to lunar, that kind of analog starts to make a little bit more sense.
Thank you. It was a great explanation. I just heard yesterday, I think, there was a program on the radio about the training, the ASCANS training, and part of that training, those that are not pilots, because not everyone comes with the military background into astronaut corps, then the 4 out of 10, I think, lately identified as ASCANs, they are in process of training, pilot training, not yet the helicopter training, but for them to fly T-38, the NASA planes. So they're in the process of being trained at Ellington Field. And I think your program is the next step for them and for future training, for future classes.
That's correct. And we found that there was a bit of a gap too when they were arriving to the T-38. So through other analyses, we decided that our non-pilot astronauts probably needed a little bit more basic flight training. So we changed that portion. So they're doing about 40 hours now on a Diamond aircraft. It's a little bit smaller, but it's side-by-side seating, which we liked as well. But that training is now local to Galveston and Ellington. So they're going to be a little bit more familiar with the local flying area, but have a little bit more time of actual stick and rudder skills and some instrument flying skills before they get into the jet. So we've changed that training a little bit because of these gaps that we were seeing, to make sure we're closing those and building this really solid spectrum of essentially basic training for the astronauts before they are at their end point for candidate training. And we can send them either to ISS or on an Artemis mission and be comfortable that they have, a significant background in aviation that we've decided is a good analog.
Yeah, right in the same program. And my background is avionics. And
Okay.
they did mention what perked my interest. They did mention about the dual control redundancy and the ability to operate that in that side by side is configuration is the instructor with the student or the someone that is learning and the ability to control and correct. And so that's the dual avionics in there, kind of that what was more interesting to me, not necessarily the training component of that, but the
There you go.
operational. Yeah.
Yeah.
Okay, well, thank you. That was a great explanation. And as I was listening, you talking about the how the transfer of the skill between the helicopter training and the lander, and it totally makes sense. Yes, vertical planes are absolutely necessary, and thinking about or thinking mode in those planes are absolutely necessary. Without training, you would not necessarily even bring that, invoke that kind of a thinking in, and again, for success on landing on the moon, we do need to have that mechanical memory, and so that is thanks to your training component will now be part of the overall the skill bag of skills for our astronauts. What lessons from aviation transfer surprisingly well to space flight operations?
Yeah, so many, which is why it's such a heavily emphasized analog. And I think for your audience, if they're not familiar or in aircraft very often, it's probably for me as the operations officer and someone being involved in developing this training, it's your ability to solve problems in challenging environments. That's probably the reason why we do so much of this is yes, there is a mechanical skill of trying to figure out what the aircraft is doing, but everything from going through procedures, whether they're normal procedures or emergency procedures, working as a team, knowing when you have a part to play in responding to an emergency, that's challenging, especially in the T-38. You've got one person in front, one person behind. Helicopters, crew resource management's a little bit different. We're side by side, but primarily it's just you start to learn how to solve problems while you're kind of at risk a little bit. Aviation always carries inherent risk. We all know that. And so I think it's learning those skills, right? That you can make good decisions when your life depends on it, and these analogs are important for that. So a lot of what we do, from map reading to working the checklist to flying the aircraft to pulling G, doing aerobatics, flying in formation, then flying the helicopters, which is even different. Now we're working potentially with 4 crew in an aircraft, running procedures and all that kind of stuff, spatial orientation. There's so many things. I have a list of training needs in the training needs analysis of all of the tasks that correspond well to an aviation analog, and I'll just tell you that it's a lot. So that's why we really emphasize flight training and continuous training for the astronauts. So they have requirements that they need to fly every quarter and every year, and we track that pretty closely because we know it's important to prepare astronauts. And there's some intangible stuff there too. The astronauts can fly the T-38 and eventually the helicopters themselves. So if you're previously trained as a jet pilot, you can take the aircraft out as a front seater, but we'll put astronauts in the back seat. So these teams of astronauts are constantly training together. And it's good to know how your friends react when air traffic control gives you a really weird clearance and you're the person in the back who has to figure out, that divert or whatever it is, or making the weather decisions before you fly. All that kind of stuff is really good data for the core, and they get to know each other in those types of environments too, right? So I think that's why these aircraft and all aircraft and astronaut training are so heavily emphasized. I just need to grab my power cord before I run out of power. Give me 1 sec.
All super interesting.
Yeah, for those that joined perhaps maybe later than Erin had joined earlier, and that you may see in on the the windowsill, there's a model of Saturn V rocket. It's yes, right there. Exactly. I think you're muted. Um,
I
actually,
am. Yeah, that
okay.
was
Okay. On my side, you weren't muted, but you're, yes, internally, yes. So you were pointing to something else on the windowsill too.
yeah. The ISS is behind me as well, but the lighting
ISIS. Okay.
that you see, yeah.
Yeah, it's that one that kind of lost completely in translation, the ISS, with the leafy greens in there covering partially. Yes.
That's right.
Okay. Yes, definitely space theme, right? In the background. Okay, well, thank you. So moving to the next question that I have prepared is that related connecting to the kind of a Artemis and so as Artemis moves beyond the low Earth orbit, how do you see crew training evolving compared to Apollo or ISS?
I think the training has always evolved depending on the mission. It was probably a little different during the shuttle era. We've got 25 years of good data on how to train for ISS, but it's evolving again, probably being a little bit more heavily emphasized with aviation analogs, a lot more sims. Obviously, we're seeing way more geology being incorporated back into training now as we're moving into lunar surface operations. So I think that the changes are making sense and they're happening pretty quickly, but we're also still having to train for two missions. So the ASCAN still have to know how to end up at the ISS and operate, but we're also making sure that if needed, they'll have some of the baseline skills for Artemis. So their introductory training has actually changed a little bit in the past 3 years that I've been here to accommodate the fact we have two missions that are kind of running concurrently. I'm not sure if that answers your question, but
For most part, I think, yeah, I agree with you that training is pretty much an ongoing and evolving. And so there's depending on the missions, depending on the the technologies, and I'm sure that there will be certain impact on to training once we get all the figure out all the infrastructure on the lunar surface and with the more the cadence increasing of the launches and the landings and the and lunar habitat and all of that is the training will be different than what it is right now because most ISS is self-contained and even though it's evolving, it's still in specific. The space is limited. It's
yeah.
finite, and so maneuverability within ISS is totally different than the maneuverability on surface. And those the utilization of the rovers and also the building in future based on ignition and the artifacts that we have seen, it looks like there's going to be the roles of the astronauts will be evolving and changing in future, not necessarily maintenance. The focus of the ISS, which it is right now in many cases, and at least for the first few years, the building out the habitat and then also maintenance of that habitat is going to be impacting the training and impacting how what and I can only imagine the exhilaration and the excitement of the first landings on the
Yeah.
moon because that the whole because of the geometry of the surface
Yeah.
and also interaction with the all the geology that will be there interacted with and explored. And so right now, again, we for ISS we're training in specific instruments, but those instruments going to evolve and change because the instruments of the collecting sample collection and then maybe assessment of those samples, packing some of the samples, and so on for transfer. And it's going to be definitely different, but it's at the same time, a lot of that is the same, probably the same, the how it's applied and how the procedures, the content of the procedure will change, but overall the approach will stay the same because
Yeah,
of the so much work we had done so far.
absolutely. So I think the only thing that's going to be consistent is that we're just going to be constantly iterating, and we're doing that right now. So the geology folks are already deeply involved because we need to know what they need and how to train it. You're taking a bunch of test pilots, primarily some medical doctors. There's not a lot of geologists in the office, so we're having to train them to be pretty decent geological technicians, which takes time. So all of that stuff is kind of being baked in. So we're pulling a lot of information from scientists, researchers, training needs analysis, all that kind of stuff, and baking it in at the lowest level to build that competency over time. And I don't see that changing because, like you said, we're going to have to be interacting with so much different stuff in the future. I'm sad I won't be here for it, but I'll certainly be watching from Canada.
Well, I'm sure you will be involved in some capacity because the connection with space never really ends. I
That's a
can
good,
tell you that.
yeah.
Yes. Okay. Speaking about Canada, just a very short comment is that you're not the only Canadian right now on uh, this venue. I see that Jake just joined, and he is a student at A&M, the Texas University, but he is Canadian. And I met him earlier this year at the conference, and I thought about him. He's a PhD student, and
Fantastic.
so future robotic operation and improvement and so on. Yes. Potentially. So he's excited to enter the career of aerospace and exploration as a uh, as a researcher, as a scientist. And
Nice.
I invited him. I thought about him when we were interacting, thinking that potentially there's always that having the Canadian background really helps, right?
Yeah. Thanks for the intro, Svetlana. Yeah, so nice to meet you. Sorry I joined the call a little late. I really wanted to hear what you had to say, but sometimes that just life just happens.
Yeah.
Yeah, so I'm studying hypersonics. I'm doing research in like ablation and reentry modeling and experiments and stuff like that. So, the uh, hypersonics world is very US focused. So hopefully I'll be able to find a way to, get involved in that and still be connected with Canada because that is the dream. But yeah, finishing my PhD this next summer. So
Awesome.
I've got some work to do to figure out how that'll happen, but fingers crossed.
Super cool. Yeah, and I think you're probably graduating at the right time. Maybe not specifically for hypersonics in Canada, but there is so much emphasis. I know you've probably been heads down in your PhD, but we are really focusing on a sovereign launch capability back in Canada. So there's
Right.
probably 5 companies now that are kind of figuring out how they're going to get, a medium-sized payloads to LEO in the next like under a decade, as they want to be able to launch it from the east coast of Canada. So we're seeing a lot of rocket startups now, which is kind of cool in Canada, and they're well funded because it's a government sort of priority at this point too. We don't want to be left behind when it comes to launch.
Yeah,
So
yeah.
super neat, and maybe we'll see you back in Canada one day. But I mean, that's super rad. Hypersonics is so cool, and yeah, I mean it's just super neat stuff. So congratulations on that.
Yeah. Oh, thank you. Yeah, I'll take another look at that, hopefully first principles modeling can extend to a few other things as well.
I would
So,
imagine, yeah,
yeah. Well, it's
Just
really nice
know
to meet
that
you.
careers are
yeah,
never
maybe.
linear.
Yeah,
Yes,
Yeah.
they
exactly.
go they go in and out, and different opportunities, and with each opportunity, both your resume and your background gets just a little bit more stronger for application in your next step. And so it's always fun. Just be
Yeah.
curious and learn more which as a scientist, I know you're doing that. So there's no, absolutely no question about that. But this was a great bridge into the next series of questions that I have prepared, which involved international partnerships. And you worked across NASA, Canadian Space Agency, and the Royal Canadian Air Force. What have you learned about building trust across organizations with different cultures and priorities? You also mentioned in your earlier comments Russians and ESA, the European Space Agency integration interaction. So what do you think? How is all this building trust across different cultures?
Yeah, how it's building trust. I think it's how these various agencies and their personnel are showing up, right? I showed up here as a Canadian Air Force helicopter pilot, seconded to the Canadian Space Agency. They vetted me as well and said, we think she's okay, and then sent me down to NASA. But I arrived here as not the first Canadian, right? There's been Canadians here since the 80s. The astronauts have built a huge amount of trust based on how competent they are and all the extra work that our core takes on because they want to be involved in the mission. So we have a core of 4 astronauts in Canada. 3 of them are permanently in Houston. Lieutenant Colonel Jeremy Hansen, who is a mission specialist for Artemis, he recently announced his retirement. But all that time that they've been here, they've been building that trust across various agencies. And both Jeremy Hansen and Josh Kutrick, who flies on Crew 13, are both former fighter pilots in Canada. So people were aware of the Air Force connection here, but the Canadian Space Agency specifically has been involved since the beginning. And I think we built a lot of trust and goodwill and technical competency that people understand and can rely on with Canadarm1 on the shuttle and Canadarm2 and the other robotics on station. And it's not just the robotics, it's our robotic flight controllers that we send down here, both from the CSA and our prime contractor for that. They're always really awesome people and they integrate right away. And so I think we're seen as punching a little bit above our weight, but so are all the other agencies involved in this giant team. But I think engendering that trust is made a little bit easier because of the reputation that other Canadians had down here specifically. There's robotics people, there's health sciences people, there's behavioral health sciences people. There's all kinds of Canadians that are kind of integrated at various levels. And I think that helps us build that trust. And it's probably the same way. I won't speak for them, but for Japan, for ESA, Russia built, half of the station. We've been working together as a team and trying to solve problems together between NASA and Roscosmos for that space station. And you've got ESA, JAXA, and all of our commercial partners too. I think we're building trust by how we show up, and everyone, I'm going to keep using this word context, but we're all interested in a safe mission, accomplishing the science objectives, and primarily making sure the crew stays safe. And so I think that's kind of how you build trust, is we all understand the intent and we just want to execute. But speaking specifically as a Canadian, it felt like it was a relatively easy transition between the 3 agencies because I understood the mission and I was just enabled to do so down here. Like I said, it's helpful when you arrive somewhere, and just by virtue of the fact that the Canadians have selected you, NASA's very happy to have you here. So there you go.
Thank you. I was trying to find real quickly that we had a Peter that we had MDA presented the history of Canadarm, and for those that want to learn more, the recording is on our SpaceGeekSpeak YouTube channel. So it's kind of interesting how the collaboration grew, and again, Canadarm1, Canadarm2, and the future versions of Canadarm, or the not necessarily version of Canadarm, but future the evolution of this technology will be used, leveraged into the surface operations. Okay, what next question is what strengths do international partnerships bring that might not exist if a single nation pursued exploration alone? Kind of your reflection, perhaps, because we heard different versions of this answers.
Yeah, I think it's just diversity of experience, right? If you're pulling the best capability, whether it's technological or experiential, through the people that you're bringing down here to participate in the mission, you're just by design are going to have a more diverse kind of problem solving capability. Something that we learned pretty in a different context in special operations is I think a lot of people see me walking down the street wouldn't have assumed that I was a special operations aviator, but I think that's deliberate, and that everyone we selected for that team, which is very challenging, you're off doing very sensitive work in very dynamic environments, often without a lot of oversight. We picked people that were different because of the experience that they would bring. So we were able to think around really abstract, crazy problems together and solve them in really novel ways because no one was exactly the same. Like if you looked at well, you can't, but if you were to look at my class of graduating pilots from special operations, not a single person had the same background. And that was by design. And so I kind of feel like NASA, whether it's deliberate or not, in pulling in all these different people, you guys have amazing expertise down here, but for the types of problems that we are dealing with, like going back to the moon, going to Mars, putting stuff in orbit around other planets, like it's crazy. So why not draw on the entire planet if you can for that type of expertise to allow you to think around some of these really abstract problems? And I think that's something that NASA has done. They've been very collaborative, especially looking at the International Space Station program. It is literally international. And Artemis too, there's a bunch of people involved in the Artemis, or countries involved in the Artemis Accords. And I think it drives that innovation, just having so many different types of people involved in it. It can be a little challenging to manage at times, I'm sure, but I think that's probably why, in my perception, it's so important to involve other countries. And if we're doing this for all of humankind, everyone should be involved in some kind of capacity and participate and share in that risk as well. Looks like Mike has a question.
Yes. First of all, thank you, Erin. That was a very good description of a lot of interactions that are necessary in spaceflight. And there's one area of technology that is growing up called HRI, Human Robotic Interaction. Not interface, not integration, but interaction.
Okay.
And that is how humans can work with a robot, and how robots can work with humans. Because I think in the future, mid future, we're going to discover that doing a lot of space exploration is a lot easier financially to use robots out in space. They can do a lot of things that humans have to have a lot of interaction and help with. Robots, all they need is energy, and they can walk outside and do many things, including setting up infrastructure for what humans will be needing, and that's on Mars. But I learned recently there's an expert in this area called she's a gal called Veronica Shabania, and I think I'm doing not a good job of her last name, but she lives in Stockholm, Sweden, and she's an expert in HRI. And maybe it would be good to have her on this show sometime, another time. But I guess my inquisition here is to identify how you think about robotics and robots in space and how they work with humans. You mentioned you're a robot expert.
No,
so
no, I'm just a fan of robotics, not an expert.
Well, that's the same as me. So, so, uh, do you see that coming along as another team that you can work with, or is that something that just is kind of on a side that you
No,
have to?
I don't think it's on the side. I'm not an expert in robotics or HRI necessarily, but I think if we look at the history of the human spaceflight program, we've had robotics kind of growing up alongside, and we know that we're going to need assistance, likely robotic assistance, for so much of this training that we're doing to get to places like going back to the moon, and even on station. The arm Dexter, which is kind of the large manipulator that we put on the end of the arm, we can service a lot of station without the astronauts, but that just helps kind of mitigate risk. Sometimes you have to send astronauts out the door to do some of the maintenance, Other times, the robotic specialist can find ways to use the tools we have outside of station to do that work for us. So I think you're going to see that it's a really tight relationship because, like you said, there's a lot of risk to humans doing space flight, but we bring some things that machines and robotics can't, but you can't do one without the other. Something I found interesting from a friend of mine who works in lunar geology. She's the person responsible for the lunar samples when they come back for Artemis 4, but the descriptions that she was getting from the astronauts just from their eyeballs on Artemis 2 looking at the surface, even though they had potentially had pictures of other parts of the moon, the pictures weren't descriptive enough. They needed that human kind of eyeballs on the situation to describe the colors, the texture, and that kind of thing. So they found that a combination of using really high-powered cameras, the technology that a lot of it was automated to get them around the moon, but they needed the humans in the capsule to make some of these descriptions to help them figure out where, what was going on the surface. And I think that's the relationship we're going to have with robotics in the future. We're not going to be able to do any of this stuff completely on our own. Humans have a very particular capability that we bring to exploration, but the robotics are going to enable that. And so I think you'll see that HRI and any other type of robotics interface or interaction is going to be really important. So I think they're a mutually beneficial team for sure. And I would never advocate to not involve robotics, but we involve robotics like all the way down in basic astronaut training. They go up to the CSA and learn how to fly the arm and interact with our robotics flight controllers and start that kind of relationship early. But that stuff's going to change so crazy in the next couple of years, I'm sure, with AI and everything else. But it's a mutually beneficial relationship for sure.
Okay. Okay. Thank you. I appreciate the information. Thank you.
Yeah, thank you, Mike, for asking, and for everyone for asking this question, and for everyone, just FYI, as I said, I have a extensive list of questions prepared. So I have about another 10 questions. And so if you can hold your questions, or you can post them, like I see Rock has been putting questions into the chat, that would be the best, because then I can go over and see if Erin already addressed through my prepared questions the answers already been covered, or if not, then we'll read over them. But as I said, it's a quite extensive list, and it is covering various aspects of both the work, technology, and backgrounds of what Erin had been involved in. And so potentially your question may have been or will be addressed in the follow-up questions. So with this lengthy explanation, hold on your questions. Thank you. And I muted myself, of course. So with the finalizing or ending our conversation about international partnership, I wanted to hear your perspective on what makes NASA CSA, Canadian Space Agency partnership is so successful, with reflection on what have been said earlier with the overall integration, international participation, and partnership.
Yeah, I think it was, in my perspective, it's been Canada's ability to solve a particular problem that NASA had put out. Like, hey, we think we need robotics. Canada answered that call. We think we need people to help with this various aspect of crew training or what have you. And Canada's like, sure, we'll come down there and help out as best we can. And you tell us kind of, what you need and where we'll focus. And that's kind of what we did. So I think that partnership extends beyond space. I've worked with Americans pretty much my entire career in the military as well. And usually what I've found, whether it's space or the military, it's just, if there's a problem to solve and we both have potential solutions, we find a way to work together. And so Canada was able to do that with robotics and a few other things. And we tend to select, just like you guys do for your astronaut program, we select really good people that just want to work. And we're happy to come down here and fill in the gaps if there are any and help out. So I think it's just honestly open communication about the needs and us finding novel solutions that are, part of the patchwork down here to make human spaceflight work.
Thank you. I think as a summary, a lot of us in space exploration have this can-do attitude, and you can put the problem or gap challenge in front and just say and ask that we need to solve this. And a lot of capable and really the innovative people will come up with the solution that would work either for this particular case or overall transferable and scaled out the option that in future will be implemented everywhere on Earth as well.
Yeah.
Thank you. Okay, moving into a slightly different area, but very much related to astronaut training, leadership and human factors. Spaceflight is often described as a technical endeavor, but it is equally a human endeavor. What qualities do you think make someone exceptional in mission operations?
Yeah, I think whether you're an astronaut or a flight controller or an engineer or researcher, most of the people that I encounter at Johnson Space Center that are involved in training or astronauts themselves are extremely humble people. And I think that humility allows them to absorb feedback and immediately apply it by kind of removing the ego, because we know that we have to iterate really quickly. And if our ego is involved and we don't take the feedback, that could potentially lead to problems in the future. And if you like expand that out abstractly, that's just extra risk that we're taking. So I think humility is probably the quality I've noticed most. We're doing really, really hard stuff, but we're also bringing in people to NASA like yourselves, who are brilliant researchers, super smart, tackling crazy problems, really, really amazing young engineers. But like day one of Spaceflight Academy, we learn about the accidents that happened at NASA, those 3 major accidents that cost lives. And I think that level sets everyone being like, okay, so our mission here at Johnson specifically is human spaceflight. And if we don't take that seriously and we're humble in our own capabilities and we don't know when to raise our hand and say we don't know and solve the problem, that could lead to a crew safety problem. So I think people really take that seriously here, and it's something as an outsider I've definitely observed in the office as well, in the astronaut office as their operations officer, that humility, ability to kind of take on feedback or self-correct as required is really important, because we're dealing not just with research and crazy technology and all that kind of stuff. End of the day, we're trying to put our friends into space and bring them back in one piece, right?
That's a great connection to the next question. And I actually will put 2 questions sort of bunched together that you may, because I think they're connected. So how do teams maintain composure and make good decisions when the stakes are incredibly high? And the follow-up is, can you share an example of when adaptability became more important than having the perfect plan?
Right. I think it's through training. We do an exceptional amount of training. If I just look at the astronauts themselves, they've got their ASCAN or astronaut candidate training that is anywhere between 18 and 24 months, depending now. And then you're selected for a mission and you do more training, usually a year, sometimes 2 years. And it's just sims. You're learning the equipment. You're in the mock-up facility, getting your hands on the same equipment you're going to encounter in space. And one of the best types of training I think we do for the next question that you had is probably putting people in the NBL. We put our astronauts in mock-ups of the suits inside the neutral buoyancy lab, and they will go through repeatedly crew rescue, tethering themselves, the actual procedures they're going to encounter in space. They're getting used to the equipment. It's an uncomfortable environment. And if I think about how an astronaut maintained composure during what could have been a really catastrophic situation, was Luca Parmentano, who was selected for Artemis 3. He was on a EVA, I can't remember with who, but he had some kind of water leak in his helmet while he was actually out doing the EVA. And it was kind of, given that it's space, the water was clinging to his head while he's outside and starting to creep down in front of his face. You're in a spacesuit at 400 kilometers above the Earth's surface, and now you have a water leak that you could probably drown in if you're not careful. But he was super chill. I don't know how chill I would have been, but he was very calm. He was composed, and I think he probably relayed a lot of that to just how much training he did, specifically in the NBL. We never obviously put him through a simulation of a water leak and him drowning in his own helmet, but because both of those crew members and the ground teams trained so extensively, they were able to come up with a solution for that. And Luca, he jokes about it now, although it was probably super terrifying, but he was also a fighter pilot, a test pilot in the Italian Air Force. So I think he's probably got a long history of managing sort of the physiological changes that happen to your body when you're stressed out, recognizing them, and working with the ground crew in a situation that was really very potentially quite dangerous. That's probably my best example of like how consistent, effective training can help you manage the worst day outside, right? And that's kind of what we saw with Luca's EVA. And everything turned out fine. There was some kind of issue with his I don't remember what the issue was, but the EVA people were able to solve it. And that whole team on the ground was also working together to make sure they were getting Luca and his EVA partner the information that they needed to make a successful, make it successfully back into the airlock.
Yeah, that particular example was very dire and very critical.
Yeah, and if you had not maintained composure, that would not have ended well, right? So, yeah, we stress test we stress test our astronauts kind of incrementally as they go along their training to make sure they're building that skill set. It's not a technical skill set. That is all soft skills, and the behavioral health sciences people or health and performance people are also involved in our ASCAN syllabuses, and we have them involved in a lot of our training needs analyses as well, because like, are we doing enough to train for those types of events when we know the astronauts have to maintain composure and still make good decisions, right? So it's a good question.
Okay, so looking ahead in future, as we prepare for sustained lunar exploration, what operational challenges do you think the public rarely considers?
I think how physically demanding it's going to be. Like, we know it's far away. We know it's the moon and there's no atmosphere. We know there's going to be issues with infrastructure to begin with, and this is very challenging, just from like a logistics perspective. But I think maybe we forget how challenging it is to be in the suit where we just don't know. And we're looking at doing a lot of lunar EVAs back to back to set infrastructure up, and that's going to be very demanding on the astronauts. So I'm sure they're prepping now, but they're going to have to be physically and psychologically ready for that kind of workload. And I think that's something that the public often maybe doesn't really think about, is how physically demanding this job is. Even though it's 0G, or on the moon it's 16G, it's going to be a huge physical load on them too. And a lot of stress, right? You're going to be operating in an austere environment, thousands of kilometers away, tens of thousands of kilometers away from anyone. And while ground control will be able to do their best to help, they're going to be kind of on their own as a bit of an isolated team. So the stress of that on people, I think, is something we probably don't think about, but they're just like everything else, they're preparing for that as well.
What capabilities do you think future mission operations will need that weren't as important 10 or 20 years ago?
Yeah, that's a good question. I mean, there's competencies in geology that obviously we're going to need, but I think we're going to, and we already emphasize it now, but the absolute teamwork and cohesiveness of that team, you're going to be in an even probably smaller area to begin with when you're in the first lunar lander. The ability for that relatively small team to operate 100% cohesively for that duration is going to be crazy. We already emphasize teamwork, but ISS, you kind of go off and do your own things throughout the day, and then you come back together. That team's going to be operating in really, really tight quarters. So they're going to have to be 100% cohesive throughout. And I think we're good at selecting people that are able to do that type of really close teamwork. But I think that's what we're going to have to really be mindful of, is how stressful that's going to be on them. And also maybe stress testing, making sure that the capability of our ground teams to be stress tested and handle unusual events. We do that already, but it's just the time factor that we have to deal with now with lunar stuff. You're dealing with a delay, but also the immediacy of issues if they creep up on the moon are going to be really challenging to deal with. So I think that's the capability. I know you're kind of probably thinking about a technical capability, but my job is mostly training humans. So I think of the human factor side of things. And for me, managing that stress is something that I'm usually thinking about when I'm like developing a syllabus, is like, how can I make this more challenging so they're getting that training, those reps at working at their kind of max. So that's what I think we're going to need.
That's a diversity of thought. It's great. Yes, absolutely. Fantastic. So if you could design one improvement for future human exploration programs, what would it be?
One improvement. Interesting. I actually don't know if I have an answer for that, because so much of what we're doing is iterative, so we're constantly improving. So it's hard for me to figure out 5 years time when I don't know exactly when we're going to end up back on the moon, what improvements need to be made, because from what I see in my perspective is, even as this training is starting, I don't know if you can see me with my hands, it's just like this constant feedback loop. So as problems creep up or things that need to be improved, that information's fed back down to someone like me at the baseline developing some of this training. So if anything can be improved, maybe it would be the speed of that cycle, I think, to make sure that we're delivering exactly what we need on time. Like we are, but it is challenging at times. So I think maybe speaking from an institutional perspective, it would be a slightly faster feedback cycle, because the teams are large, but that also means that information sometimes takes a little while to filter down to people at the lowest level, like myself, who are supporting the astronauts specifically in like a very small piece of their puzzle. So that would be nice, but that's institutional factors that all of us can't deal with specifically. But that would be my biggest improvement if I could make one, and that applies to literally every team I've ever worked on.
What you touched on, it's called very often a balancing act, because it's such a complex, challenging, because on one hand, and also too much of the push and pull, because on one hand you want it to be faster, but on another hand you want it to be also safe and making sense, because sometimes at times one part of the team can see this one particular thing as improvement, but not knowing all the facets of impact may be negative in certain portions that you need to at least assess and have that trade study of, is it a benefit
Yeah.
overall, or it could be a tremendous impact that you should not even touch.
No, it's super.
Because the snowball effect is not just affect the immediate, it also the side effects that potentially you may not want to even consider.
Yeah, I don't know how to fix it, but you're right. Like you pull on one string and something happens somewhere else. It's a crazy problem to integrate, but maybe one day we'll get it 100% perfect.
Yeah, and I think in many cases, in those assessments, AI can help us and will potentially, but we'll see. We shall see. Okay, well, thank you. And so now going into a little bit more of the human factor, kind of a personal reflection. After spending years helping make human spaceflight possible, what still gives you goosebumps? I know
Seeing your
one
friends.
thing for me, for instance,
Yeah.
but what's yours?
I think seeing your friends and coworkers go to space, especially the folks that have never been before, and then you watch the launch, and then you hop on console and you speak to them for not usually the first time, but you speak to them in space, and they kind of look like they're just still getting used to zero G, and that's kind of neat. And knowing that you had for me, like a tiny part to play in that whole situation for them is really neat. And similarly, I think I'll probably never be able to look back on watching my boss, technically, Jeremy Hansen, go around the moon. Watching his launch was just mind-bogglingly cool. Like I know this guy, we've worked together before, and seeing another Canadian officer just strapped into a moon rocket, like that was crazy. That thinking about that gives me goosebumps, but supporting human spaceflight and seeing these people go to space, rock their science, and come back is always gives me goosebumps.
Thank you. I think it's never ending thrill of
Yeah.
being involved, and the goosebumps are keep on coming, right? And watching that rocket launching and this intensity and knowing that some of your friends are actually on top of that rocket and going into the unknown is just amazing feeling and
Mhm.
goosebumps territory for sure. I remember that I mean, it never, the thrill continues. I remember first time I met an astronaut in real life and sitting with Frank Culbertson, and I have interacted with him for number of, I don't know, for a few times on and off. And then one day he came and visited my apartment in Moscow. And then when he was sharing pictures of his family, one of the pictures had this funky looking plane. And the commentary was that his family was meeting him after his second flight. I had I had to take a moment that and what the second flight to where? Because it did not. I had no idea that he was an astronaut, and that was a pre-internet time. So
Right.
it totally did not look into his background, what he was, other than that he was working at NASA.
Right.
So nowadays it's much easier to look at the background of people and look at the LinkedIn or whatever,
For
the
sure.
multiple places. Yes. Well, thank you. Yes, that this having your friends on top of the rocket is wow. What is one moment from your NASA experience that you'll carry with you for the rest of your career? You think,
Yeah.
at least right now.
Well, there's a bunch, but I think the one that, I mean, aside from watching your friends go to space, was probably the first time as a certified Capcom, they let me loose in mission control, and I was sitting the console by myself. The first shift I did in mission control on my own was pretty cool, and I think I'll remember that for a long time because you're like, wow, this is, I'm speaking on behalf of not just the flight control team, but these are public loops that anyone can listen to, which you realize after, especially for live stream events. But you're speaking on behalf of NASA and, for in my case, the Royal Canadian Air Force and the Canadian Space Agency. So it was a huge privilege to kind of be given that kind of trust. And apparently, I have a bit of an accent when I'm speaking. I didn't know this, but I will hear it sometimes. We have multiple frequencies that we're monitoring. Not all of them are public. Sometimes it's folks in the subsystem specialists, and I'll get teased sometimes when I say something, and I'll hear it in my ear as I'm talking to the astronauts that, oh, there's the Canadian again. But it's been a really big privilege, and I think I'll remember that for the rest of my life.
Has your definition of exploration changed after working so closely with astronauts and mission teams?
No, I don't think so. I think I knew before that exploration at its core is teamwork. I think if anything, it sort of solidified my understanding of exploration being like the ultimate team sport, and that's really cool to kind of see that real time working here at Johnson Space Center.
Out of all the questions that you experience in the past, what question do you think you wish that people ask more often about mission operations?
Mission operations. That's a good question. I kind of, it would be nice if people understood or maybe a little bit more curious about the background. It's great about the astronauts, but there's, in the background there are so many other people that are supporting the mission here. I love my astronaut friends, they're fantastic, but they get all the attention. But there's so many, I'm not talking about Capcoms, I'm talking about the 20-year-old engineers that show up to Johnson Space Center and becoming, I don't know, an operation support officer, mission control person who's responsible for essentially the nuts and bolts of the space station. This is their first job. And the effort that it takes to go from a junior engineer to a front control room certified flight controller, or like the robotics flight controllers, I think it takes about 8 years or something. The dedication and effort that goes into the support teams here is crazy. And I wish we were able to kind of get people talking about that more. It's great. The blue flight suits are fantastic. They do awesome stuff, but everyone supporting those missions, that is what I wish people would talk a little bit more or ask more about in mission operations, is just how incredible these teams are. And it surprised me in Spaceflight Academy that some of the engineers, this was their first job, but they are in it because they love it. And I think that's great.
Have you heard any misconceptions about NASA or astronaut operations that you would like to correct?
Not really. I don't tend to participate in some of the internet drama when it comes to things, but I think for the most part, the people that I interact with have a pretty good understanding. But I think the most important thing is why I keep talking about it is, in my experience, in my perception, and in my professional, although short professional career here at NASA, the focus has always been on crew safety. And I think we will sometimes get lost in, oh, well, they ended this mission early, or this happened with Starliner, and this, that, and the other. They don't care. And like, NASA cares deeply about making sure that everyone, that crew is safe. That is our whole job here. So I'll keep screaming it from the rafters that, everyone that I know is deeply involved and centers crew safety in every decision that they make, even right down to how someone like me and the other helicopter pilots are building a syllabus. Like, we are not doing this just because we think it's fun. We're doing this because we want to make sure our crew is safe at all times, as safe as we can make them in this type of environment.
Okay, this is the last question that I have right now, and I didn't share it with you.
Oh, no.
So when people look back at this era of Artemis and renewed lunar operations 20 or 30 years from now, what do you hope they'll remember? Not just about the mission, but about the people who made it possible.
Yeah, that's a good question. And I hope they look back and remember how excited, happy, pumped people were. If I went and watched from the Artemis control room viewing gallery, and these people, a lot of whom are my friends, these flight controllers, were so focused on their job and making sure this mission was successful. I've never seen people, I have seen a lot of people at the top of their game between special operations and competitive sports, but it was a vibe. It was an absolute vibe in mission control, and people were so focused and so excited to be there. It's hard to communicate that through, the video cameras and mission controls and the pictures that we saw, but that's what I want people to remember when we look back on this, is that you have a bunch of relatively young people that were able to start us back going to the moon with Artemis 2, and it was a total vibe. For some people, this is working Artemis was their first job. They started 3 years ago, and now they were able to accomplish a very successful mission, and I hope the rest of them go like that too. But the most important thing for me is always people and teams, and NASA has a particular knack of building really good teams that are excited to do the jobs that they're doing and can execute when it's really hard. So that's what I hope we can remember.
Awesome. Okay, I see that Rock had posted 3 questions, and I'll read them in as they were asked. Do you have to train for mission-specific ops just like astronauts? And how do you keep with the station knowledge and changes to the station? Do you have to take refresher courses every so often?
Yeah, so as a CAPCOM, we have our kind of basic CAPCOM training, takes about a year. And once you're qualified to sit console, we have refresher training we do pretty much every quarter. And if you're doing your minimums as a CAPCOM, which means I think we're doing about 3 shifts a month, I tend to do about 6 or so. Every time you sit console, there's a requirement for you to read through a bunch of documentation. So questions and answers that people have had, open questions still. And so you're constantly getting the vibe of what's going on. And we also obviously have a network of CAPCOM leadership people that have specific roles in informing us when things are changing. So we're updated pretty frequently about what's going on in station. And yeah, so about every quarter we're doing emergency training specifically, and then every time you sit console, you're refreshing yourself on what's going on. There's a lot of flight notes or like internal documentation to read when we're on console.
Have you got an internal bid system so you can assign to the Capcom position for more dynamic or other more exciting events that was related to the specifically boring or the certain time night, for instance, being Capcom and not necessarily having too many activities?
I think we call that quiescent, not boring. It's just a standard day, which is honestly any time that nothing is really happening that we really need to get involved in other than science is a great day. But in terms of special assignments for dynamic events, it sort of depends on your background. I had a really big interest in robotics, probably a little biased given where I'm from. So the lead Capcom, he's my ops boss. He owns the branch. He kind of assigned me to the capture mission for NG-23. I didn't have long enough to do another capture mission, but I was going to continue with robotics if the Air Force didn't decide to bring me back to Canada. For other things like EVAs, that's a very dynamic event, and you need a special qualification essentially to do that. Either you're an astronaut who's done an EVA before, or you're one of our engineers like Tess Caswell, she's the lead Artemis Capcom now, but she used to work in the branch CX and did all of the engineering and suit stuff and also dies in the NBL. So as a Capcom, we're happy to kind of let her run with that stuff because of her background. So not really an internal bid system. The chief of the Capcom branch will usually, he knows his people pretty well, so he'll assign stuff to people that make sense for their personalities. So some people get assigned to crew docking because they're really good with the vehicle or they have previous experience as a different type of flight controller. For me, it was just a super big interest in robotics, so I got a couple robotics missions.
Okay, next question is kind of interesting, and you may or may not. Oh, well, it will be interesting to hear the answer. Is how is the decision for the astronaut wake-up music made? Does Capcom has any say in the selection? And the final was cutting Pink Pony Club just before chorus on Artemis to deliver it.
So I'm not an Artemis Capcom. Like I mentioned, my buddy Tess Caswell is. She's one of the leads. She wasn't working that day. I can't remember who it was. It was a male Capcom. But we don't do wake up music for the ISS very often. But for an exploration mission like Artemis, they did, and I'm pretty sure that was astronaut driven. They had selected the playlist. But from what I'm tracking, it was not deliberate. They just had a limited comms window to work in. So he had to cut in so he could start the morning planning conference. That's my understanding, but I'm not an Artemis insider, so I'm not exactly sure.
Okay, now I wanted to open floor for about, probably will limit to a maximum 5 questions if we have any questions from the audience. I know that Mike had asked, and yes, and Rox said thank you for the answers.
You're welcome.
Okay. And if there's no questions, okay, Mike, do you have a question?
Yes, I had one other question, and that is, I think the Apollo program might have happened before you were even born, considering that you look pretty young. So I was wondering what you thought about Apollo 13. And as you know, Apollo 13 had a problem on the way to the moon, and they had a lot of interaction with the operations people to save their lives coming back. And do you have any thoughts about that, and what we have learned from that you think is important?
Yeah, I mean, the Apollo program, I think, kind of solidified in a lot of ways how we structure mission control and the importance of the flight director and where people sit even in the flight control room, and the importance of our back control, like our back room people as well, the subsystem specialists. So we simulate not something as dire as Apollo 13 generally, but we simulate and train pretty much based on something similar. So when something goes wrong in our simulations, you have the front control room people who are probably learning how to do that job, and they have to pull information from either our mission evaluation room or their backroom subsystem specialist and come up with a plan. And I think a lot of that capability and know-how came from incidents like Apollo 13. So over time, we've adapted and learned from situations like that. And so you find that these nested teams inside mission control are really quick at getting information, solving a problem, and telling flight about it, because we've learned from situations like that one person can't necessarily come up with the plan. We have to work as a team, but we have to do it quickly. So in order to make ourselves efficient that way, we've leveraged all of these old experiences for sure. I thought it was a great movie, and it did come up a couple times during Spaceflight Academy, which is the first thing we do when we come here as flight controllers. And essentially what it's emphasizing is how important teamwork is. And I'm going to go back to that humility comment I made before. There was no ego in those rooms. Well, there may have been a little bit because it was the 60s, but the whole point was that we had to come up with a solution quickly to save lives. And so if there was a piece of information missing, someone had to say something. So people were seeing problems, talking about it, and fixing it. And that pedigree, I think, is sort of still distributed amongst NASA. So teamwork and humility, those are, and Gene Kranz, actually, I met him not long ago. He came by Mission Control. It was amazing. He developed sort of our list of things that we aspire to be in Mission Control. And I'll tell you, teamwork and humility are the first two things on that list. So that's still, and he was there during that time. So that experience drives a lot of how we make decisions at NASA still today.
That's great. I never met Gene Kranz, but I did work on Apollo program at North American Aviation in the early days.
Nice.
And so I think lessons learned is a very important part of any mission. Even if everything goes right, you
Yeah.
still should have a lessons learned part at the end.
Yeah, and we do every single increment. When the crew comes back, they're feeling a little bit better and they're rested. Large portions of the increment team for that mission will sit down and go through a debrief. And we debrief literally everything, every sim run, every flight, every EVA practice in the pool, every live EVA they do on station. They will debrief it, because we know, and you know from experience, that we have to learn from any mistakes or things that went well to keep people safe in the next go. So definitely a thing that we do.
During that mission, during Apollo 13, my boss came to me. I was a trajectory engineer,
Oh,
and my boss came to me and he said, on the way back, if their angle to the Earth's atmosphere is a little too high, they'll skip off and be lost in space forever. And if it's a little too low, they'll burn up in the atmosphere. And so he looked at me like, we need a solution to make sure that they get into that little tiny space of entry. And I had no idea. I
crazy.
said, I said, well, I hope they have good luck because I don't know what to tell you.
Nice. That's
What a
great.
responsibility, right? Just
Yeah,
right has to be right.
Yeah, just figure it out.
yeah, figure it out. But that was an experience, I'll tell you. Well,
I
thank you
can
very much, Aaron. I appreciate your information. Thank you.
Yeah, and thank you for your previous service to the program. It's appreciated.
Yeah, thank you.
Okay, well, since there's no other questions, I wanted to quickly remind everyone that next week we will have a presentation about space suit, also very relevant and very important for both the sustaining our presence in low Earth orbit as well as on the surface for surface operations. And for this program, Erin, thank you so much for spending your Saturday morning with us and for sharing your incredible journey. Your experiences reminded us that human spaceflight is made possible not only by remarkable technology, but also by dedicated people, teamwork, and international collaboration. We truly appreciate your service and your leadership and everything you've done to advance human exploration. I wish you all the best in your new assignment back in Canada, and I hope to welcome you back to the Space Geek Speak in the future. thank you again very, very much.
Well, thank you.
And
I
everyone,
appreciate it.
thank you for participation.
Awesome. Well, thanks so much, Svetlana. I appreciate you reaching out because this was really neat. And I love talking about space. But
Join us from wherever you are on Earth or off or whatever. Saturday morning here.
sounds good. Well, thank you so much, folks.
Mhm.
Thank you and have a great weekend, everyone. We'll see you next
Yeah.
Saturday.